Hi, this is Stephen Carson coming at you from St. Louis, Missouri, in these United States. Very excited today to finish the series on the foundation of modern science in the Middle Ages. I think it addresses some false history that began right at the beginning of what we would think of as modern science with Galileo and so forth, and we'll directly address some of the fake news that Galileo spread, maybe understandably in a way. I'll give a sort of a slightly sympathetic view, but fake news nonetheless. And it's certainly something that I think has been pushed hard ever since, and maybe even more strongly in the last century or two. Anyway, I'm going to try to finish this book. It's two pretty meaty chapters. I'll do some skipping around in this first one, but the last one, where it really gets into why did science develop in the West and not in is under Islam or in the Byzantine Empire, in Eastern Christianity. That is an amazing chapter, and there's not much I'm going to want to skip there. So I'm looking forward to that. Okay, what a business, and then we'll get going. Share with friends. I never say this. Share the channel with friends, please. Or actually, even better, share a particular video you like, and like the videos. It does help the channel. And support is gratefully received by a number of friends at Subscribestar. Look at the video description for the link. Most people donate $5 a month. Or you can just use it to do super chats where no money goes to Google and more money makes it to me and less to the middleman. I really like Subscribestar as a platform. It has been serving me well. And as far as I know, I've never heard of them kicking anyone off, unlike, say, Patreon and YouTube. Or, the way YouTube demonetizes people. Subscribestar, yeah, I literally, tell me if you've heard of it, but I haven't heard of anybody getting kicked off. Because their politics are dissident or whatever. So it's nice to have a stability in that platform. Okay, so thanks to those guys. All right, let us get to it. I'm going to share the book. Before we go to the text, just want to show you again. This is the book we're finishing up today, Foundations of Modern Science in the Middle Ages by Edward Grant. Really good. And I will mention it. I'm saying it now to help me remember it. The fellow who recommended this book to me is Edward Fazer. He has a book called Aristotle's Revenge. Let's see if I can read back. Oh, it's not backwards. Aristotle's Revenge, The Metaphysical Foundations of Physical and Biological Science. This kind of covers a different topic, but closely related. And if I remember at the end, I'm going to just read you like 2 paragraphs from his preface or intro or whatever that gives you an idea of what he covers. I'd love to cover it on the show, but probably gets a little too deep philosophical waters for what I want to do on this channel. But I certainly want to let you know about it because thanks to Ed, who, by the way, I know. I got to know him some time ago, a long time ago. Thanks to Ed for recommending on Twitter the book that we're finishing up today. And then I am not a philosopher, but I gather that his works in philosophy are really good. And this one sounds really interesting. I'm tempted to just read it for my own benefit. Okay, so let's go to the book. We are finishing up the last 2 chapters, chapter 7 and chapter 8. Chapter 7 is going to finish the survey of the Aristotelians, the medieval natural philosophers, who are the, a little cheeky title called them the Aristotelian Scientists, or you could call them the the ones who led into what we think of as science, however you want to think about it terminologically. But I think sort of the whole point here is that there's some discontinuity, but there's also some continuity. And that's really what he wants to emphasize. The discontinuity has been overplayed, and he wants to emphasize some of the continuity from the natural philosophers, the Aristotelian natural philosophers of the Middle Ages, into early modern science with Galileo and so forth. Okay, so we'll do this chapter. I'm going to skip around a bit, skip over some bits, and then really focus on the final chapter, which talks about, sort of summarizes everything that's been done in the book and pushes further into asking that big question, why only in Western Europe? Seems pretty bold claim, right? Well, claim. We know it only happened in Western Europe, but anyway, we'll get to that. Okay, so medieval natural philosophy, Aristotelians, and Aristotelianism. So what was the method of the Aristotelians? One of the biggest things they used was the quaestio, the question, the most widely and regularly used format for natural philosophy in this period. It had a disputational structure, and it has become almost synonymous with the concept of the medieval scholastic method. So there were some variations, but just to get some structure in your mind of what this might look like. First, you would have an enunciation of the problem or question, usually beginning with a phrase such as, let us inquire whether, or simply whether, in the Latin utrum. For example, whether the earth is spherical, whether the earth moves, whether it is possible that several worlds exist. And then this would be followed by one or more, sometimes as many as 5 or 6, solutions supporting either the negative or the affirmative position. They would tend to put, how do I put it? If they were going to take the affirmative, they would put forward the negative arguments first and then finish with the affirmative. That's the way they tend to do it. So how do I turn the page here? Okay, here we go. So the initial opinions, which would ultimately be rejected, were called the principal arguments, or in Latin, rationes principales. Then, and this is where the book messed up the Latin, or I'm sorry, the Kindle version messes up the Latin. So let me make sure I don't mess it up here in the book. There we go. Yeah. So you'd have the initial opinion, the principal arguments, principales. Then you would have oppositum, the opposition, the opposite opinion would follow. Okay. And the reason this term opposite or oppositum was so appropriate is because medieval authors were responding to questions that required yes or no responses, right? So they'd set it up as a yes or no question. They'd give something going one direction on it, and then they'd give the opposite. And then after giving the principal and the opposite arguments, they might further clarify. They'd have a section maybe clarifying and qualifying their understanding of the question or explaining particular terms in it. And so I'm going to quote at length here from John Buridan to give you a flavor of this. So in a question asking whether it is possible that several worlds exist, John Buridan explained not only that the term world could be taken in many ways, but also what he meant by several, or plurality of worlds. So here's Buridan. World, mundus, can be taken in many ways, and one way is the totality of all beings. Thus the world is called universe, universum. World is taken in another way for general and corruptible things, and in another way for perpetual things. And so it is that we distinguish world into this inferior world and into a superior world. And yet world is taken in many other ways that are not relevant to our present discussion. But world is taken in another way that is pertinent, namely as the totality of heavy and light bodies. And it is about such a world that the question, whether it is possible that several worlds exist, inquires. And with regard to this, it must be noted that the plurality of such worlds can be imagined in 2 ways. In one way, existing simultaneously, as if outside this world one other such world existed now. In another way, they exist successively, namely one after the other. So you can see he's very carefully clarifying all the different ways that the question could be taken and focusing in on what he wants to discuss, right? Okay, then you get your qualifications, clarifications done. And then the author was ready to present his own opinion. So there's the original whether, the utrum, what is the question. Then there's arguments for or against. Then there's the opposite of that. And then clarifications, and then finally conclusions. To conclude the question, the author responds sequentially to each of the principal arguments enunciated at the outset. Okay, so that's the structure. And then a questions treatise would consist of a bunch of questions. So, for example, Albert of Saxony included 107 questions in his Questions on the 8 books of Aristotle's Physics, 35 questions in his Questions on the 2 books of On Generation and Corruption. John Buridan considered 59 questions in his Questions on the 4 books of Aristotle's On the Heavens, and 42 questions in his Questions on the 3 books of Aristotle's On the Soul. So they do it in like a commentary style, like they're doing a commentary on often Aristotle, not always, but often Aristotle. But then break it down into questions, and then those questions could go into great depth. Okay, so sometimes efforts were made to link the questions, but it was more usual that each question stood on its own, was considered independently, as if unrelated to any other question or topic. So in medieval scholastic natural philosophy, the focal point was on the independent question and the differing opinions that it generated. The object was to resolve or determine each question. Okay, again, going to skip a bit around in this chapter. Medieval natural philosophers, he talks about some other forms of literature that they would do, and I'm skipping most of that. But medieval natural philosophers laid emphasis on analysis, not synthesis, right? So they didn't tend to tie these things together. They were more focused on analyzing the particular question in a deep way. There were treatises, tractatus, or treatises, and this would be a more systematic consideration of a subject, because it says that Nicole Erasme, for example, would regard these themes as unsuitable for the questions format, and so they did have other formats they would use, right? Okay. Yeah, again, kind of skipping over the different other modes. Worth noting the Summa, because of the famous Summa Theologica by Thomas Aquinas. Summas in theology and sentences commentaries were logically arranged genres of scholastic literature. So those were more meant to be a comprehensive treatment of a subject. But as you may know about Aquinas' Summa, it is structured internally with these questions, right? In the medieval style. Okay, anyway, the focus in this study is on the questions literature, though other literary forms, including the tractates, also played a role. So the purpose of the literature of natural philosophy was to describe and analyze the structure and operation of the cosmos with all its objects and creatures. Now, we've covered this before, and he just sort of summarizes here, so I'm not going to go into great depth, but he talks about what is the big picture Aristotelian cosmic frame, and he says the cosmic frame was on the whole remarkably simple, and it gets into the spheres, which I used for the had the graphic designer use for the thumbnail, a medieval drawing of the spheres. You have Earth in the center, you have the lunar sphere, and then through the planets. The sun's actually in the middle. Mars is outside of the sun. I don't remember why. And then finally, the sort of containing sphere on the outside. The spheres or orbs nested one within another. This is how they're picturing the cosmos, right? So that's the celestial or cosmic frame. Then you have the terrestrial region, which begins just below the concave surface of the lunar sphere, going to the geometric center of the universe, which was considered to be the Earth was at the geometric center of the universe. Again, not going to go into this in great detail, but as we've discussed previously, It talks about the natural place of fire and air and water and earth and so forth, the four elements as Aristotle had conceived them. This is a little bit interesting. Because the celestial region was held to be incorruptible, it was judged more perfect and therefore nobler than the terrestrial region. And so it was thought that the incorruptible celestial bodies govern the behavior of corruptible organic and inorganic bodies in the terrestrial region. So influence radiated from the outer spheres to the inner spheres, right? Or from the celestial spheres into the terrestrial region. This governance was accomplished by the continuous radiation of a variety of influences flowing unidirectionally from the heavens to the earth. This sounds a lot like astrology, right? You're being influenced by what's going on out there. That's influencing what's happening down here, even down to influence on individuals. And indeed, as we'll see, astrology does come up here and there in the Middle Ages. It is something that's there. So by the simplicity of this fundamental structure, picture of the orbs and the elements and so forth, the series of nested concentric orbs embracing the terrestrial and celestial regions, this cosmic scheme satisfied European scholars psychologically and intellectually for some 450 years. Right, so from the earliest part of the story we've been telling, which is the 12th century, really, up until we get into where modern science really kicks off and starts questioning a lot of things about this picture. Yeah, my friend says the Earth is still the center of the observable universe, since that universe is centered on the observer, which is us. Good point. Okay. All right. If Western Europe, if Western Europe was largely agreed on the macro structure of the world, it didn't reach consensus on the manner in which the great variety of specific cosmic activities occurred. And this is really where the natural philosophers were in contention with each other. So let's talk about how the knowledge schema, how did they think about and divide the subjects, the areas of knowledge. In metaphysics, Aristotle had divided the sciences into theoretical, concerned with knowledge, practical, which concerns conduct, and productive, which deals with the making of useful objects, right? And then theoretical science, he further divided into three parts. First, theology or metaphysics, which considers things that exist separately from matter or body and are unchangeable. That is, spiritual substances and God. So first, metaphysics. Second, mathematics also treats of things that are unchangeable, but the only things that are abstracted from physical bodies and therefore have no separate existence, such as numbers and geometric figures. So they're unchangeable in the sense that, 2 + 2 always equals 4, but 2 + 2 = 4 is just an abstraction from dealing with physical things, right? Physics, finally, third area is physics, which treats of things that not only have a separate existence, but are changeable and possess an innate source of movement and rest. Okay, let's see. So in its broadest sense, natural philosophy in the Middle Ages was concerned with the study of bodies undergoing some kind of change. That is that third section. Natural philosophy was not focused so much on metaphysics and mathematics. Mathematics and metaphysics both were played roles, instrumental roles, but the focus of study of natural philosophy was Aristotle's physics, right? Bodies undergoing some kind of change, meaning moving, growing, shrinking, undergoing a phase, what we would now call a phase transition, right? From liquid to gas. All that sort of stuff is in physics, Aristotle's physics. So, or as an anonymous 14th century author put it approvingly, the whole of movable being is the proper subject of natural philosophy. All right. Okay, so that sort of corresponds to what we would mean by science now, right? So physics would include, or actually, is he about to get into this? Okay, yeah, sorry. He's about to get into the further distinctions. Okay. Mathematicians studied the same bodies as did natural philosophers, but from a radically different vantage point, right? The mathematicians sought to abstract and study the geometric properties and features of material bodies. And so they were primarily concerned with the measurable and quantifiable aspects of bodies, not in the bodies themselves. This is why you get, they'll abstract away from certain things in like geometry and geometry, and let's treat this as if it's a point, an infinitely small point or whatever, because we don't really care about the shape of the body or whatever. We're thinking about something else. Sciences that involve the application of math to natural phenomena, such as optics, astronomy, and statics, were characterized as middle sciences, scientiae medii, because they were assumed to lie between natural philosophy and pure mathematics. Okay, so that's optics, astronomy, statics are sort of in the middle. So you got math, optics, astronomy, statics, and then you have just straight up like physics. As it had been conceived by Aristotle and by those who wrote on the classification of the sciences, magic was excluded from natural philosophy. Astrology played a role, but only because it had been an integral part of astronomy and also played a part in medical studies. If alchemy was considered, it was only because it was bound up with Aristotle's matter theory. But though, as he says, maybe, there's whatever their significance for the history of science, magic, astrology, especially as it pertained to human fate and fortune, alchemy, and other occult sciences were not officially taught in the natural philosophy curriculum of medieval universities. So it's going to become clear later. It's going to become clear later that this is an extremely important statement. A distinction he's making here. Okay, we'll come back to this at the very end. But the fact that magic, astrology, and alchemy are outside of the natural philosophy curriculum, whereas physics and biology and so forth are inside, makes a huge difference in what comes to be considered modern science. So we'll get to that. Okay. All right. So what were the kinds of questions? And here's where I'm going to skip through. He kind of like explains each question and stuff and tries to help you understand a little. I'm going to really just give you a flavor here. He says that the aggregate of questions that were considered in natural philosophy might reach about 600 or more. But the totality of questions on these Aristotelian treatises constitutes the heart of medieval natural philosophy. So if you make a list of sort of the main questions that these guys were considering over those hundreds of years, that's the heart of the core curriculum, you could say, right? Is to think about these questions, study these questions, and what different conclusions and arguments people have made about each of these questions. The author here proceeds in a cosmic order. He starts with questions about the outermost parts of the celestial region, what might lie beyond, and then downward to the lunar orb, and then on to the upper terrestrial region, and then downward to the Earth itself. So thinking about that orb model, we're going to start at the outer orb. We're going to work our way in, right, with some of these questions. So just totally sampling here. Here are the questions, as usual, formed in this, starting with the term whether, to make it into a yes or no question. Whether the universe could have existed from eternity. Really key question, right? Because Aristotle assumed no creation and that the world just was always there. whereas a biblical view says that there was the world was created. There was a time when there wasn't a world, right? That leads to, obviously leads to whether the world was created. This also led to natural philosophers to wonder about the possible existence of other worlds, about the possible existence of an infinite void space spread out beyond our world. Because remember, Aristotle thought there must be something there in all places. But the medieval philosophers started to wonder if maybe there could be a vacuum or a void, and maybe that could be what's around our world, or between worlds. Let's see. A major concern about the created world was, did God make it perfect? What did it mean to characterize the world as perfect? If it were perfect, could God have made it even more perfect? Material composition of the finite world was a theme. Did a fixed number of elements exist from which everything was made? And, this gets into the four traditional elements from Aristotle: earth, water, air, and fire, plus possibly ether, and so forth. Let's see. I'm really jumping around here. Was the density of celestial bodies different from the density of terrestrial bodies? Theologians were much interested in whether God had created light on the first day, and if so, what its nature might be. Interesting question that I think we're still trying to figure out. Was each celestial body the source of its own light? Or were the planets essentially devoid of light and dependent on the sun for all the light they received? So are we seeing light, when we see light from the moon or from Mars, is it generated from that celestial body, or is it a reflection of sunlight? Very good questions, right? Okay, now moving to the terrestrial region, the four elements, they were concerned about whether elements retain their identity in a compound, right? Because they recognized that these elements would come together to make the things we actually interact with. The elements were almost viewed as potentially just an abstraction, but maybe you could still figure out what elements were in there somehow. Could one element be generated directly from another? Could an element exist in nature in a pure state, not in a mixed state, right? The natural philosophers asked whether bodies that move upward or downward have internal resistances, whether a resistant medium such as air or water is essential for motion to occur. It then seemed natural to inquire whether a separate extended vacuum might exist, and if so, could bodies move through it with finite speeds? Although Galileo, Descartes, and Newton made some of their greatest contributions to science in the kinematics and dynamics of motion, many of the questions proposed in the Middle Ages form part of the history of those solutions. And we'll get to the relationship between the early modern scientists and these questions of the Aristotelians before them. One of the most important questions, whether after leaving the hand of the projector, a projectile is moved by the ambient air or by an impressed force or impetus, right? They considered a variety of questions about the Earth as a whole. One of these concerned its sphericity, especially the manner in which the Earth's mountains and irregularities could be reconciled with its sphericity. So they knew the Earth was round, but there's bumps on it. So how do you think about that, right? There's bumps on the Earth. There were also questions about the Earth's relative size. Is the Earth like a point in comparison to the heavens? Is the magnitude or size of the Earth smaller than that of certain planets? Is the Earth smaller than Mars? Good question. They considered the Earth's location. Was it fixed in the center of the world? The distribution of its matter. Did the Earth have the same center of gravity and magnitude? And its status at the center of the universe. Was the whole Earth at rest in the center of the universe, or did it rotate on its axis? Again, very good questions, right? Okay, now I think I mostly skipped this. He talks about the techniques and methodologies of natural philosophy and the abstract methodology. The only thing I'm going to pull out here is that he does spend some time on William of Ockham, and sure enough, he is going to focus on what you think he is. He mentions that Occam derived an epistemology that has been characterized as radical empiricism. That means we can't reason our way to some of these things. We just have to observe to figure things out, and be inductive. Roger Bacon insisted that in natural philosophy, experience had to confirm demonstration. Therefore, reasoning does not suffice, argued Bacon, but experience does. So this is the empirical approach, right? We've just got to go out there and look to figure out certain things in natural philosophy. So demonstrative science, that means science where you like experiment or observe, right? It was discussed and considered important. It only played a small role in the usual problems that were treated in the regular questions treatises by the natural philosophers. So yes, it is true. The what we think of as modern science really introduces what he's calling demonstrative science or experiments and observation. The natural philosophers are really using reasoning, right? Thinking things through. Let's see. Okay, methodologies that were actually used. Okay, sorry, give me a sec. Okay, right. So he focuses on John Buridan, who used the strategy, who excelled in the strategy of the natural philosophers. He calls him perhaps the most brilliant arts master of the Middle Ages. When you hear arts, think, when you get a Bachelor of Arts, right? Art school, that area of learning. A confirmed empiricist, Burden believed that humans could understand nature's operations in terms of cause and effect. He accepted the truths of revelation as absolute. He had no overt problems with his faith. He acknowledged that God could do anything that was considered impossible by natural means, but he was not attracted to the physics and cosmology of what God might have done. He was interested in focusing on what we could figure out by reasoning and observing nature. In a question that inquired whether the grasp of truth is possible for us, he argued that with regard to natural science, truth is attainable, provided that a common course of nature obtains in natural things. And in this way, it is evident to us that fire is warm and that the heaven moves, although the contrary is possible by God's power. So he says, yes, God can change the laws of nature, but what we can study, we can't really study that if God's just going to do something miraculous, right? Can't really study that in natural philosophy. So we're going to just set that aside and we're going to focus on what happens when nature does its typical thing, right? Common course. So the law of nature within the Aristotelian conceptual framework was not one of rigid necessity, but simply that of the usual or ordinary occurrence. For example, defects occur in human births, but they're regarded as anomalous. Natural causes usually produce their intended effects. So the focus is on what typically happens, right? Acknowledging that sometimes something unusual or miraculous happens, but let's understand how things generally work in nature. Let's focus on that. So although God could alter the course of natural events, Buridan insists that in natural philosophy, we ought to accept actions and dependencies as if they always proceed in a natural way. Neither the occurrence of miracles nor anomalous chance events affect the validity of natural science. So this is called inductive generalization. We observe and we see that, most of the time, it works this way, and we'll go with that. Okay, so let's see. Then the principle of simplicity. This is where we get back to Occam, right? This is another key tool for them. In its most basic form, it derives from Aristotle, who declared at least 4 times in his biological works that nature does nothing superfluous or in vain. During the Middle Ages, the principle of simplicity was frequently employed with various twists. In its broadest sense, we know the principle as Occam's razor, named after William of Ockham. Although, as we shall see, Occam intended his principle of simplicity or parsimony as it has been frequently called, to apply only to thoughts and not to things, he gave various versions of it that were equally applicable to either. So, in other words, this is a powerful tool to say, yes, we could try explaining things in this complicated way, but let's just not. Let's take a simple, straightforward explanation as our default, right? Until someone shows that isn't going to work, and we need to make it more complex. And he goes into some examples of that. In addition to simplicity, scholastic natural philosophers also used arguments from nobility and hierarchy. So, for example, in the terrestrial region, inanimate objects were located at the lowest rung of the ladder in terms of nobility or hierarchy, followed by plants, animals, and humans. And then as you go beyond the earth, things were considered nobler, and therefore better the greater their distance from the earth. And then various people argued with that, but that's sort of the basic idea. Another tool they had were counterfactuals, which we discussed in last episode. Counterfactuals, secundum imaginationem, that is, according to the imagination. Sorry, my Latin pronunciation is classical, not medieval. Let's see, the counterfactuals are really key, and as I don't think I illustrated, but from studying the Austrian School of Economics, I can tell you that counterfactuals are recognized and respected as a tool for isolating certain concepts in economics and so forth. Okay, now what about the role of math? Math becomes a big deal in modern science, right? He says the application of math to problems of natural philosophy was fairly common in the Middle Ages. Originally they talked about qualities in a non-mathematical way, but a rationale was eventually provided for the quantitative treatment of the whole spectrum of qualities. So a quality like redness or hotness was believed to be something that could grow or shrink in the same manner as weights, for example. Weight can get heavier or lighter, redness can get more red or less red, right? So medieval natural philosophers believed that 3 degrees of redness could be added to 2 degrees of redness to produce 5 degrees of redness. So they're starting to think in a, let me use the term correctly, in a cardinal kind of a way about these qualities and starting to turn them into numbers, which means they become something you can think about you can apply math to, right? So yeah, well, that's what he says. Thus, one could treat qualitative changes mathematically. Because of this association of motion with qualities, significant theorems about motion were derived that forever linked the medieval doctrine of intention and remission of forms with Galileo's contributions in the 17th century. So those who wrote on this subject of the use of math between the late 14th and 16th centuries came to be collectively called calculatores, calculators. This is where we get the term. An apt term that signified their effort to measure, by mathematical techniques, the increase and decrease in intensity of qualities. The original calculators, calculatores, were fellows of Merton College, Merton being in England, during the 1330s and 1340s. And I would mention the names, but I don't really recognize any of them, so I don't know that that's going to be helpful. But he gives a list of names. All right, so I'm going to skip on here. Right, so he says, should we, therefore, he's been talking about the application of math and natural philosophy, right? Should we view the medieval application of mathematics to natural philosophy as the real beginning of mathematical physics? And he says, not really. The two approaches toward mathematical physics differed considerably, if not radically, Those who were instrumental in producing the scientific revolution, such as Galileo, Descartes, Kepler, and Newton, sought to apply mathematics to real problems in the physical world. By contrast, medieval applications of mathematics to natural philosophy were usually of a hypothetical character, divorced from empirical investigation. So they used math to think through these hypotheticals, as opposed to hypothetical as opposed to real world application, right? Indeed, he says, the medievals had virtually no interest in testing their hypothetical conclusions against the real world. It was natural philosophy without nature, as John Murdoch put it. Except for counterfactuals that considered natural impossibilities or speculations about hypothetical possibilities that may or may not have involved the application of math, most of the non-mathematical questions posed by medieval natural philosophers on the natural books of Aristotle were about the real world. The replies were also thought to be real solutions about that world. So, the question format, right? They were trying to think about the real world most of the time. Okay, use of natural philosophy in other disciplines. He talks about theology. I'm just going to skip that bit. Not saying it's not of interest, just going to kind of skip it. This is interesting, though. He talks about medicine. Almost from its beginnings in ancient Greece with the works of Hippocrates, medicine has been intertwined with natural philosophy. So extensive was this interrelationship that the Hippocratic author of On Ancient Medicine sought to counter its influence by arguing that philosophy is useless for the study of medicine. But for Aristotle, natural philosophy and medicine were intimately related. The greatest of all Greek physicians, Galen, was also a philosopher and found numerous occasions to intrude natural philosophy into his writing. Excuse me. Because of the structure of the universities, the links between natural philosophy and medicine were considerably strengthened during the late Middle Ages. At the great medical centers, such as those at the universities of Paris, Bologna, Montpellier, and Padua, many physicians, if not the majority, who received their degrees in these institutions had matriculated through a university arts program, perhaps even receiving a Master of Arts degree prior to entering as a student in the medical faculty. Now, this is going to be a running theme, as we'll see, that before going into other areas, they expected you to have some mastery of natural philosophy. So before you got into medicine, you learned some natural philosophy. So the average university-educated physician was thus trained in both arts and medicine and could presumably interrelate them more authoritatively than ever before. Now, university-trained physicians were a minority of healers, right? Most people working as doctors or whatever they called them back then were not university-trained. But the medical literature was produced overwhelmingly by physicians with university backgrounds. So you had the natural philosophy coming into the medical literature. And then briefly on music, of the quadrivial sciences, the quadrivium, right, of arithmetic, geometry, astronomy, and music, the first three were not penetrated by natural philosophy. To the contrary, it was natural philosophy that absorbed some math and certain basic elements of astronomy. But music did have some influence. He found, he cites questions on music where the author found occasion to introduce the intention and remission of forms applied to sound and to stringed instruments, right? So getting to the physics of music. The possibility of motion in a void, the perfection of species, relationships between infinites, first and last instance, and a number of other topics were brought into the discussion of music. Okay, characteristic features of medieval natural philosophy. Many medieval natural philosophers believed that questions and problems in natural philosophy could not be scientifically demonstrated by reason or experiment. Only probable, plausible, or conjectural responses could be provided for hundreds of questions. The primary tools of analysis were metaphysics, theology, and counterfactuals, often in the form of thought experiments expressed in the language of natural impossibilities. Within such a context, experience and observation played small roles. You may know from Einstein that thought experiments continue to be used in science into the 20th century, and I'm sure still. So this is a tool that continues to be used. Now, he brings up the fact that these questions would be considered and different natural philosophers would come to different conclusions on the questions. And he asks, were medieval natural philosophers disturbed by their seeming inability to come to widespread agreement on most of the questions they posed? And he says, if they were, there's no evidence of it. In this Blasius of Parma says, in contrasting the derivation of mathematical conclusions from first principles, declared that in natural philosophy, this is not the case, what we can do in math, because the matter of natural things is not subject to demonstration. Okay, well, again, from Austrian economics, I know exactly what's being said here. Derivation of mathematical conclusions from first principles is called the deductive method. We use the deductive method in math a great deal, though not always, and definitely in geometry, and also in economics. So happens, the field I know best, the science I know best. But they're saying that in natural philosophy, like in physics, they would tend to use induction. You couldn't just start from first principles and figure this stuff out. So, medieval natural philosophers were unlike early modern scientists in two significant ways. They did not regularly employ experiments as a means of gaining knowledge about the world, and they lacked a useful concept of scientific progress. Now, this author is going to put a lot of emphasis on the notion of progress, which, we have reason to be suspicious of a big emphasis on progress. I think another reason to question this emphasis, though I kind of see where he's coming from, is the Kuhn, in the Structure of Scientific Revolutions, talks about how science doesn't tend to just continue to build stepwise on itself, but you have instead these paradigm shifts, occasional paradigm shifts. The new paradigm is accepted for good reason, right? But he sort of calls into question whether the new paradigm is always, that the best way of thinking about it is just the new paradigm is just simply progress from the old paradigm. He kind of leaves you thinking maybe it's just different or something, with pros and cons, each paradigm having pros and cons, Anyway, fascinating book, by the way. KUHN, Structure of Scientific Revolution, strongly recommended to your attention. So for Aristotle, every substance possessed an inner principle that guided its development and existence, and that almost always operated harmoniously with its external environment. The idea of science is to identify and understand the workings of these inner principles or forms. In a world of such substances, controlled experiments would do little good because they would interfere with the regular environment of any given substance and thereby prevent us from learning about its true nature. Now, this sounds frustrating in one sense, right? Because Aristotle is discouraging the experimental method. On the other hand, you could consider that he's having some foresight and seeing ahead to what we now recognize as a problem. And I'm going to forget the name of it, right? But this issue that when you measure things, you can affect the thing you're being measured, right? If someone can drop it in the chat. Shoot, I'm forgetting the guy's name. There's a name for this principle, that what you're measuring the act of measuring can change what's being measured. Aristotle takes it too far and it's like, well, it's not worth bothering with. Okay, sorry, distracted by Mercy and talking about adverts midstream. Yeah, I maybe I should twiddle with that in the future. Sorry about that. Okay. Right. So Aristotle doesn't think you should do controlled experiments because you'll interfere with the environment and change the thing you're measuring, right? And he's actually got a point in some cases. But not experimenting at all was not a great move, right? So the routine incorporation of experiments into science was a contribution of the scientific revolution. I don't know how influential it was, Aristotle's view there. Did he kind of put people off, you know? The Heisenberg principle. Thank you, Gregory. Yeah. Or uncertainty principle, right? That's the principle that when you observe or measure, you change the thing observed or measured by the act of doing it. So yeah, it wasn't crazy what Aristotle was thinking there. Yeah, and then he asked, did medieval natural philosophers have a concept of progress? Like I said, I'm not going to focus on this that much, but he says natural philosophers did not perceive their role as one of promoting or celebrating the advancement of knowledge. They just kind of didn't think about it that way. Okay, so because medieval natural philosophy was almost wholly based on Aristotle's natural books, it seems reasonable to call those who studied these works and wrote commentaries on them Aristotelians. It is but a step from this to the term Aristotelianism, which signifies this whole body of literature that was produced by these folks. Although problems about departures and alleged departures from Aristotle are of interest, they represent a relatively minor problem during the Middle Ages because Aristotle's natural philosophy was completely dominant in Western Europe between 1200 to 1450. It had no rivals. So Aristotle's frame was the paradigm that they were working with then, right? And it does get thrown off in important respects as we go into the early modern science period. But that was the frame that everything we're talking about here was within. Only in the I'm anticipating what he's going to say. Only in the 16th and 17th centuries was Aristotelianism first seriously challenged. So it reigned in Western European thinking for hundreds of years. We got an introduction into Western Europe of new worldviews around this time, and this process began in the second half of the 15th century when the works of Plato were translated from Greek into Latin and continued into the 16th century. Thus began another great wave of translations. We started the story with all these translations of Aristotle, right? And Islamic scholars commenting on Aristotle and so forth. There's this great wave of translations that really kicked off this period that we've been studying here. And now we get another wave of translations. And this time, almost exclusively from Greek into Latin, because you might remember there was a lot of translations from Arabic in the 1100s. And so you get new ideas, doctrines of Stoicism, Platonism, Neoplatonism, Hermeticism, and atomism. That's the idea that things are made of little tiny atoms, right? One classical Latin treatise played a significant role in the new science. So this one was in Latin, but it just was obscure, wasn't well known, and it became well known at this time. Lucretius had a Latin treatise called On the Nature of Things, De Rerum Natura. This emerged in the early 15th century to become a major cosmic system and the most complete report of atomism known. And it served as a counterweight to Aristotle's hostile account. Aristotle was opposed to atomism. And up to that time, that had been the only major exposition of atomism in Europe. That means Aristotle's critique of atomism was all they knew of the idea. With Lucretius, now they were getting a positive statement of this view. And so you started to get a break. Aristotelian and natural philosopher just always meant the same thing, basically. With the introduction of these other points of view, you had natural philosophers who were not necessarily Aristotelians. They were atomists, other frame. Principles to which all medieval natural philosophers subscribed and which none challenged. And this is what makes them Aristotelians. What are these fundamental principles and truths? Foremost among them are that there is a radical dichotomy in the world between the celestial and terrestrial regions. We would question that now, right? We'd have a unified view of physics between how physics works here and how physics works in space. But they were not thinking that way. Let's see, further assumptions of the Aristotelians, that there are 4 terrestrial elements, earth, air, fire, water, right? That there are 4 causes that operate in the world, that there are 4 primary qualities, that there is an ultimate cause of all motion, the prime mover, and that the earth lies immobile in the geometric center of the universe. Okay, let's see. So, they started to observe problems in the Aristotelian frame, some of these assumptions. In the 16th and 17th centuries, the problems increased for the Aristotelian point of view, and Aristotelians were no longer a homogeneous group. A few self-proclaimed Aristotelian natural philosophers even adopted the Copernican heliocentric system, or elements of it, such as the axial rotation of the Earth. So they were trying to stay within Aristotelianism and sort of stepwise adopt some of the new scientific ideas that were coming along. And we'll talk about how that went shortly. Despite having no real rivals during the Middle Ages, Aristotelianism was not a rigid body of doctrine slavishly defended by its adherents. Their view was that Aristotle spoke the truth. This is Albertus Magnus. Okay, important guy. Aristotle was greatly admired, and Albertus Magnus, though, says, Aristotle spoke the truth, for they say that nature set up this man as if he were a rule of truth in which he demonstrated the highest development of the human intellect. But we expound this man in diverse ways, as suits the intention of each one of us, right? So they did not regard Aristotle as infallible, as we highlighted. Some of the Muslim thinkers, philosophers, did. They basically said one guy said he's not. No one's found an error in him in 1,000 years. But the Western Europeans didn't see him that way. The attribution of infallibility would be warranted only if Aristotle were a god. But if, however, one believes him to be but a man, then without doubt he could err, just as we can too. So they had various ways of dealing with, they had this huge respect for Aristotle, but they were developing their thinking, right? So they would depart from Aristotle, but they would like to try to save him from the embarrassment of error. Talks about Thomas Aquinas doing this. Oresme rejected as false 2 rules of motion that Aristotle expressed in the 7th book of his Physics, and the author goes into detail on that. But he sought to save Aristotle by admitting that he might have had the right formulation, but it got messed up in translation, right? So it's like, it's not that Aristotle's wrong, we just have a bad translation, right? And having suggested that, then he said, well, maybe Aristotle did fail to understand it, and he fell into error. So they tend to be, it's a little bit hard for me to comprehend, but they were very respectful of Aristotle. The key thing for us is that they allowed for Aristotle to be wrong, which some others didn't, right? And so they were kind of locked in and weren't able to progress beyond Aristotle. Yeah, okay. Anyway, enough of that. So the point is their respect for Aristotle, which often bordered on reverence, did not prevent them from taking numerous significant departures from his plain intent. And there's 2 kinds of departures that may be distinguished. The first were substantive, either based on perceived discrepancies, inconsistencies, and weaknesses in Aristotle's system, or expansions of ideas that Aristotle may have merely suggested or left undeveloped. The second kind were hypothetical assumptions about the physical world that were impossible by natural means in Aristotle's philosophy. These were attributed to God's infinite and absolute power. So for the first kind of departure, we would have the assimilation of eccentric and epicyclic orbs in Aristotle's system of concentric spheres, and the manner in which they affected Aristotelian cosmology and physics. Also, the relationship between celestial and terrestrial matter, the change from motive causes that were external, such as air, to internal or impressed forces, impetus or inertia. The ways in which qualities vary, or to use the medieval expression, the intention and remission of forms or qualities. Of the hypothetical assumptions in the second category, some were derived from articles condemned in 1277. We went through that whole history and how that, which seemed like a restriction on the natural philosophers, actually seemed to sort of free them up to think about things that it sort of pushed them away from Aristotle in ways that ended up being fruitful. So they thought about things, especially things that lie beyond our world, namely the possibility of other worlds and the possibility of infinite void space. So he talks about the attempt to stepwise turn Aristotelianism straight into modern science, and he says it didn't work. Aristotelianism could not be transmuted into anything resembling Newtonianism. So it was a revolution. To call it a scientific revolution is fair in that sense. And he asks, okay, well, why couldn't Aristotelian natural philosophy just reform from within and sort of stepwise change into modern science? And he gives a couple reasons. Aristotelianism was too all-encompassing and unwieldy. Most of the opinions and interpretations in Aristotelian natural philosophy were essentially irrefutable, giving them an air of indestructibility. You didn't have mathematics, experiment, and prediction playing a significant role. So it was hard to come up with counter arguments or proofs that could address some of the deeper assumptions of Aristotelianism. Individual Aristotelians simply adopted some of the new ideas and proceeded to incorporate them into the available mix of Aristotelianism, which just made it grow larger and more complex, if not incoherent. Again, if you're familiar with Kuhn and Structure of Scientific Revolutions, then you know exactly what he's talking about. A paradigm gets to a point where it becomes, you're having to make too many modifications. It's lost that simplicity. You're making too many modifications to deal with counter arguments to the system or observations that the system can't explain, and the system starts to just become a mess, conceptually messy. So when mathematical physics reached a stage of development in the 17th century where it could provide explanations for and predictions of phenomena that were impossible within Aristotelian natural philosophy, the latter's fate was sealed. Aristotelianism did not evolve into anything else. It simply faded away. Now, one thing that really confuses me here is he says that the discovery, two big things had an impact here. The discovery of the New World by Columbus in 1492 destroyed the ancient and medieval view of the Earth. I don't know what he's talking about. He says, it made European scholars realize that Aristotle's knowledge of the earth and that of the ancients generally was not only greatly limited, but also often flatly wrong. I don't know what he really means. As I've discussed previously, Columbus was not innovative in saying that the earth was a sphere. That was well understood. Remember the spheres, right? So it was well understood that from the ancients that the earth was a sphere. So Columbus was not overthrowing that. Columbus also got the size of the earth wrong, and the others that were warning him not to take the journey actually had it right. They just didn't know that the New World was there. They were correct that had the New World not been there, Columbus would never have been able to reach Asia, right? Which was his goal, to reach China. So I don't exactly know what Columbus overthrew. Anyway, the second one makes a little more sense. Galileo did to the cosmos what Columbus had done to the earth. He revealed the inadequacy of ancient and medieval knowledge. So using the telescope and everything started to make people question whether that simple model that Aristotle had of these spheres within spheres, it wasn't just real. It just was not fitting what we were seeing through the telescope. Okay, now, so this is, he ends by saying, enough has now been said about medieval natural philosophy as a subject and discipline. We must now see what role it played in laying the foundations of modern science. Okay, so I had to get through that chapter, and I feel like I buried the lead, but this is the good stuff. How the foundations of early modern science were laid in the Middle Ages. This is the final chapter, and it's just juicy. I love it. Okay, take a drink. Although science has a long history with roots in ancient Egypt and Mesopotamia, credit where it's due, it is indisputable that modern science emerged in the 17th century in Western Europe and nowhere else. The establishment of science as a basic enterprise within a society depends on more than expertise in technical scientific subjects, experiments, and disciplined observations. After all, science can be found in many early societies. For example, in Islam, until approximately 1500, mathematics, astronomy, geometric optics, and medicine were more highly developed than they were in the West, those specific sciences, right? Indeed, the West learned these subjects from translations of Arabic treatises into Latin. But, and here's where the author really puts his thesis, science was not institutionalized in Islamic society, nor was it institutionalized in ancient and medieval China, despite significant achievements in these various empires or societies, right? Science can be found in many other places, but it was institutionalized and perpetuated in none. So we never started to build a ever-growing body of knowledge that had an institution behind it. That had never happened in the history of the world until the birth of modern science in Western Europe. So after some 3 centuries, the overwhelming consensus is that modern science began with the likes of Copernicus, Galileo, Kepler, Descartes, and Newton. And he's giving the thesis that he disagrees with. He's going to tear apart, right? It began with them, and it has no connection with the preceding centuries of scholastic natural philosophy. Indeed, it is widely believed that the new science triumphed in spite of the obstacles posed by reactionary Aristotelians. So, Galileo and everything, they had to fight the Aristotelians to give birth to science. They owed nothing to them. But he says he's going to spend the rest of this chapter, arguing against this, right? And summarizing everything that's been presented in this book. The contribution of the natural philosophers on various aspects of motion, both Galileo himself could not actually enhance them. So we think of modern science, we're given the story that modern science just de novo came out of Galileo and so forth, right? But in fact, there's certain aspects of modern science that were already there, and Galileo just carried them forward. There were big changes, but there were also some continuities. Sophisticated discussions about the Earth's possible axial rotation were also impressive, and Copernicus could not improve upon them. Medieval ideas about other worlds, and especially about infinite void space, played an unacknowledged role in shaping the cosmos that was being constructed by the new science. So he says the links between medieval and early modern science that I propose are independent of specific claims about this or that influence in this or that science. Here's his argument. A scientific revolution could not have occurred in Western Europe in the 17th century if the level of science and natural philosophy had remained what it was in the first half of the 12th century. That is, just prior to the translation of Greco-Arabic science that was underway in the latter half of that century. So the story he's telling is things really, science really freezes in Western Europe from, I don't know, the 5th century or 6th century or something like that, until you get these translations coming from the Arabic world and then straight from translating straight from Greek in the latter half of the 12th century. That's where you begin this fertile period of natural philosophy. It is in the Latin Middle Ages in Western Europe that we must look for answers to questions such as, why did science as we know it today materialize only in Western society? What made it possible for science to acquire prestige and influence and to become a powerful force in Western Europe by the 17th century? The answers to such questions are to be found in certain attitudes and institutions that were generated in Western society from about 1175 to 1500. So the book is called The Foundations of Modern Science in the Middle Ages, and this is his argument in this chapter. We didn't get modern science in 1200 or 1300, but we got foundations that were absolutely necessary for modern science to come about later. So these attitudes and institutions were directed toward learning as a whole and toward science and natural philosophy in particular. Together, they coalesce into what may be appropriately called the foundations of modern science. They were new to Europe and unique to the world. So, in the first 7 chapters of this book, he described the new factors that transformed Western Europe from an intellectual embarrassment to an intellectual powerhouse. He'll now use 2 distinct approaches to show why collectively they formed the foundations of modern science. First, the contextual changes that created an atmosphere conducive to the establishment of science. And secondly, he'll examine certain features of medieval science and natural philosophy that were favorable to the development of the scientific revolution. Okay, this is a little wordy how he says this, but let's see if we can understand what he's getting at with this first thing. The contextual preconditions that made the scientific revolution possible. And he lists 3 preconditions. First, the translation of Greco-Arabic works on science and natural philosophy into Latin. You know, what happened in the 1100s. In particular in the 1100s, kicked off in the 1100s. Secondly, so he points to the institution itself of the university as really, really key. And third, the emergence of the theologian-natural philosophers. That is, theologians who were schooled in natural philosophy. And that third one, don't underestimate it. It's really, really key, and it's going to be more clear when we get to the point of contrasting with other civilizations where science didn't arise, as we know. So first, translations. Spent a lot of time on this at the beginning of the series, but, you know, credit where it's due. Because of the importance of the translated works, the civilization of Islam must be allotted a considerable share of the glory for the Western achievement in science. Translations out of Arabic of Greek works, and, to be fair, Muslim philosophers, natural philosophers, who were thinking about those Greek works, writing about them. This all really kickstarted things in the West. So credit where it's due. There's enough glory here of science to share. So we don't need to be stingy, just need to be accurate. So he says we can talk about Greco-Arabic or Greco-Islamic science as a key foundation, right? Although science in the West might have developed without benefit of this Greco-Arabic legacy, the advent of modern science would undoubtedly have been delayed by centuries, if not yet still lie in the future. So the really key to the timing of all this. Okay, so that's the translations. Second precondition, the universities. The formation of the medieval university with its corporate structure and varied activities. Nothing in Islam, China, or India, or in the ancient civilizations of South America was comparable to the medieval university. It is in this remarkable institution and its unusual activities that the foundations of modern science must be sought. So the university is key, and we're going to explain why in a number of different ways here. The evolution of medieval Latin society permitted the separate existence of church and state. each of which was willing to recognize the separate existence of corporate entities such as the university. So is he going to spell that one out? Okay, I don't know, but let me just be clear here. Well, he is going to spell it out later, but having a separate church and state leaves room for there to be other things that don't just get subsumed into a singular institution that's sort of ruling everything. Because church and state are a little bit in contention in medieval Europe, and as I always like to emphasize, there were multiple small polities contending with each other in medieval Europe. There wasn't a single empire over medieval Europe. So at various levels, you had competition, I guess you could put it. And this allowed for the separate existence of corporate entities like the university to arise and have an independent existence. So the universities of Paris, Oxford, and Bologna were established by approximately 1200, shortly after most of the translations had been completed. So a nice little bit of timing here, right? The translations furnished the emerging universities with a ready-made curriculum, one comprised primarily of the exact sciences, logic, and natural philosophy. So you get these translations, and you get the rise of the university. It's all happening at roughly the same time, okay? And he points out what the translations were of in particular, right? If those translations had been primarily of treatises in literature, poetry, and history, the university curriculum would have been radically different. But the translations were overwhelmingly in the realm of science and natural philosophy, right? So what you get with the university and the curriculum of those early universities is the institutionalization of science and natural philosophy. Very interesting. And as he's saying, historically new to have something like this. The curriculum of science and natural philosophy established in the medieval universities of Western Europe was a permanent fixture for approximately 450 to 500 years. Courses in logic, natural philosophy, geometry, arithmetic, music, and astronomy constituted the subjects of study for the baccalaureate and Master of Arts degrees. For the first time in history, an institution had been created for the teaching of science, natural philosophy, and logic. Also, for the first time, an extensive 4 to 6 year course of study in higher education was based on a fundamentally scientific curriculum, with natural philosophy as its most important component. These disciplines served as the core curriculum for all students and were virtual prerequisites for entry into the higher disciplines of law, medicine, and theology. And that'll bring us to the third point shortly. Everybody had to study science, whether you were going to do medicine or whatever, or theology. That'll be key in a moment. You had to study science or natural philosophy, right? And this was for centuries. This was the case in Western Europe. As universities multiplied during the 13th to 15th centuries, the same logic, science, natural philosophy curriculum was disseminated throughout Europe, extending as far east as Poland. So that was the basic curriculum. Without the tacit approval of church and state, that curriculum could not have been implemented. To a remarkable extent, church and state granted to the universities corporate powers to regulate themselves, thus enabling the universities to determine their own curricula, to establish criteria for the degrees of their students, and to determine the teaching fitness of their faculty members. And we went over this in a previous episode in this series. By the way, the whole series is linked. There's a playlist I put together. The whole series, along with the first video, is actually about the Industrial Revolution in the Middle Ages. But then the rest is this series about the rise of science. And we go into more detail about the nature of the university and its independence as an institution. So here is the key question. And if you understand how things have played out in other societies, which we'll see shortly, other civilizations, you'll see why this is such a key question. Why did a Christian society, at the height of the Catholic Church's power, readily adopt a pagan natural philosophy, Aristotle, right, as the basis of an extensive educational program? Why did Christians enthusiastically embrace rather than reject such a program? Well, this goes back to the very beginning of the series, chapter 1 of the book. Christians had long before come to terms with pagan thought and were agreed for the most part that they really had little to fear from it. Okay? On the contrary, the introduction of Greco-Arabic natural philosophy and science in the 12th and 13th centuries was welcomed as vital to intellectual life. So they could have reacted differently. Other civilizations did. They could have reacted differently to all this new literature coming in, this new Aristotelian literature, but it was greeted with enthusiasm, almost universally. We discussed earlier in the series some exceptions and some pushback, but what really carried the day was the enthusiasm for this learning. Aristotle's books were made the basis of the university curriculum by 1255 in Paris. Long before that, at Oxford, churchmen were eager to familiarize themselves with the work of Aristotle, as a striking statement from Albertus Magnus bears witness. In Cologne, Aristotle began his commentary on Aristotle's physics. This is a little bit before 1250. The first of a lengthy series of Aristotelian commentaries he wrote for his fellow Dominicans. And here is his explanation of why he's doing this. Okay, this gives you an idea of the atmosphere. Our intention in the science of nature is to satisfy, in accord with our capacity, brothers of our order, begging us for the past several years now that we might compose a book on physics for them, of such a sort that in it they would have a complete science of nature, and that from it they might be able to understand in a competent way the books of Aristotle. Although we consider ourselves insufficient for this task, nevertheless, since the requests of our brothers would not cease, finally we have undertaken what we had often refused, vanquished by the pleas of certain ones among them. So he's like, okay, guys, I'll teach you about Aristotle. Okay. Manuscripts of Aristotle's works and the works of his commentators were multiplied and disseminated in large numbers, and when printing came along, they printed them often and widely. Okay? So just huge reception in Western Europe to this stuff. Whatever the state of the universities in the 17th century, because there's arguments that they'd kind of gotten a little sclerotic at that, these venerable institutions had already done their foundational work. They had shaped the intellectual life of Western Europe. Their influence was everywhere. Okay, I am pushing my voice, so I'm going to get something for that. It'll take me just a moment. Fortunately, I keep some things nearby that I can use for that purpose. Oops. Okay. I've learned from reading to my children that sometimes just a little tiny swallow of alcohol and my voice is back in action. All right. My academic agent mug here. All right. Where was I? Right. Okay. Now, finally, so the first condition was first precondition for all this were the translations. Man, that really worked. My voice feels great. Second was the universities. The third are these theologian-natural philosophers. Why is this so important? This is really interesting. Okay. So third and final precondition for the scientific revolution was the emergence of a class of theologian-natural philosophers. That is, a class of individuals who were not only trained in theology, most had theological degrees, but who also had previously attained the degree of Master of Arts, and so were thoroughly trained in natural philosophy. Their importance cannot be overestimated. If theologians at the universities had decided to oppose Aristotelian learning as dangerous to the faith, it would not have become the focus of study in European universities, right? We're talking about a development that goes over hundreds of years. If early on they were like, and that almost happened, right? As we discussed, there was a bit of pushback. If they decided, this not going to take us in a good direction, then it wouldn't have been approved as something to be a regular course of study in European universities. People would not have continued to think about it, develop it. We would have never gotten modern science. Without the approval and sanction of these scholars, Greco-Arabic science and Aristotelian natural philosophy could not have become the official curriculum of the universities. The development within the universities of Western Europe of a class of theologian-natural philosophers was extraordinary. Not only did they endorse a secular arts curriculum, but most believed that natural philosophy was essential for a proper elucidation of theology. As evidence of this, students who wished to matriculate for a theology degree were usually required to have acquired a Master of Arts degree. So before we let you get a theology degree, you got to study natural philosophy. Arts masters had been forbidden to treat theological problems. That was a rule they had, an oath they made them take, starting in 1272. So it fell to the theologians to apply natural philosophy to theology and theology to natural philosophy. And so because they were trained in both disciplines, they were able to do this with ease and confidence. Whether this involved, for example, the application of science and natural philosophy to scriptural exegesis, like understanding the scriptures, the application of the concept of God's absolute power to hypothetical possibilities in the natural world, or the invocation of scriptural text to oppose or support scientific ideas and theories. So they were playing back and forth across these different areas, right? Theologians had a remarkable degree of intellectual freedom to cope with such problems and rarely allowed theology to hinder their inquiries into the physical world. The relatively small degree of trauma that accompanied Greco-Arabic science and natural philosophy into Western Europe, and the subsequent high status that science and natural philosophy achieved in Western thought, were in no small measure attributable to the class of theologian natural philosophers. Despite having some anxiety about natural philosophy during the 13th century, theologians came to embrace it. Indeed, some of the most noteworthy accomplishments in science and mathematics during the Middle Ages came from theologians, as the names of Albertus Magnus, Robert Grosseteste, John Petcham, Theodoric of Freiburg, Thomas Bradwardine, Nicole Oresme, and Henry of Langenstein bear witness. These were all theologians who made big contributions to natural philosophy. By the late Middle Ages, Western Christianity had a long-standing tradition of using pagan thought for its own benefit. As supporters of that tradition, medieval theologians treated the new Greco-Arabic learning as a welcome addition that would enhance their understanding of Scripture. The occasional reactions against natural philosophy, as in the early 13th century when Aristotle's works were banned for some years at Paris, and in the later 13th century when the Bishop of Paris issued the condemnation of 1277, ought to be interpreted as relatively minor aberrations when viewed against the grand sweep of the history of Western Christianity. And reminders, right? It could have been that ban spread, and they were like, yep, Paris is right. We should ban this everywhere. That's not what happened. English universities like Oxford continued to study Aristotle while Paris didn't. So it instead of spreading, it was contained to Paris, and eventually Paris stopped and went back to studying Aristotle. Paris, removed that restriction. So the three preconditions just discussed, the translations, the universities, and the theologian natural philosophers, laid a foundation for the emergence of modern science because they provided an environment that was conducive to the study of science. If no translations of Greco-Arabic science and natural philosophy had occurred in the 12th and 13th centuries, and Europeans had been compelled to elevate their intellectual discourse without external assistance, it is inconceivable that a scientific revolution could have occurred in the 17th century. It would have delayed the timing, right? Nor could such a revolution have come to pass were it not for the long-standing existence of the science natural philosophy curriculum of the medieval university. Many of the major problems that were confronted and often resolved in the 16th and 17th centuries were inherited from the Middle Ages. Without these problems and without the long tradition of natural philosophy in the medieval universities, there would have been little to discuss in the 17th century. And without the support of the theologians in the church, the medieval universities would have been unable to institute the science, logic, natural philosophy curriculum that began Western Europe's long, uninterrupted involvement with scientific thought and problems. So, to help us appreciate these elements, and this is where really his argument becomes really exquisite here. To appreciate the importance of the theologian philosophers to the emergence of modern science, it is instructive to compare the medieval European experience, Western European, in relating natural and philosophy and religion, with the way in which these two disciplines were related in the civilizations of Islam and Byzantium. So this, for me, I first ran into this comparison between Western Europe, Islam, and Byzantium in Rodney Stark. And he had a sort of theological explanation, which I think also is reasonable. Reasonable to consider a reasonable aspect of this to bring into this. But this author comes at it in a different way, and I think it makes a lot of sense. Because here's three sort of rival civilizations alongside each other, and only one of them gives us modern science. So why? Why is that? He thinks there's good reasons here. So let's start with medieval Islam. In the Islamic world for many centuries, like from the 9th to the end of the 15th century, the level of science, especially in the exact sciences and medicine, far exceeded the level in Western Europe, right? You may recall that in the Middle Ages, the early Middle Ages, the Saracen Empire viewed Western Europeans as barbarians, really unsophisticated, right? And they had reason for that. By the close of the 15th century, however, Islamic science seems to have lost its momentum and entered a state of decline. Well, what happened? Okay, we're going to open up what was going on in the Islamic societies a little bit to understand this. So, in Islam, there were two kinds of science. The Islamic sciences were based on the Quran and Islamic law and traditions. And the foreign sciences, or pre-Islamic sciences, embraced ancient Greek science and natural philosophy. That's how they thought about these two things, right? Over some 4 or 5 centuries, many scholars in Islamic society, including those who were Christians and Jews, absorbed Greek science and natural philosophy and added much to them. Nevertheless, the theologians and religious leaders who were the guardians of orthodoxy in Islamic society did not warmly receive those disciplines. Remember, in Western Europe, Aristotelianism was Aristotle, and thinking about Aristotle was warmly received. It was not in Islam. Philosopha is how this philosophy was said in Islam. The great majority of Islamic theologians did little or no philosophizing and probably knew little about Greek philosophy, in stark contrast to what we see in Western Europe, right? If they were aware of it, they probably rejected its use in connection with the Quran. Most Islamic theologians would have considered even the suggestion that Greek philosophy was needed to defend Islam and the Quran as blasphemous. Their interests were largely confined to the Quran, to Islamic law, and to the traditions of Islam. So you're a theologian, you study the Quran and sort of related things, right? You don't go off looking at Aristotle. Most Muslim theologians were convinced that on certain crucial issues, Greek logic and natural philosophy, especially Aristotle's natural philosophy, were incompatible with the Quran. Now, Western Europe contended with this also, right? But kind of dealt with it in a different way. So, greatest issue that divided the Quran from these disciplines was the creation of the world, which is upheld in the Quran and the Bible, but was denied by Aristotle. Another serious disagreement arose in connection with the concept of secondary causation. I had never known about this. Very, very interesting. In Islamic thought, the term philosopher was often reserved for those who assumed with Aristotle that natural things were capable of causing effects, as when a magnet attracts iron and causes it to move, or when a horse pulls a wagon and is seen as the direct cause of the wagon's motion. On this approach, God was not viewed as the immediate cause of every effect. Okay? By contrast, most Muslim theologians believed, on the basis of the Quran, that God caused everything directly and immediately, and that natural things were incapable of acting directly on other natural things. So this is, how do you put it? A very high view, maybe high is the wrong word, a very totalistic view of the role of God in the universe, right? If you know anything about Islam, you might have an inkling of why they're thinking this way. Although secondary causation is usually assumed in scientific research, most Muslim theologians opposed it, fearing that the study of Greek philosophy and science would make their students hostile to religion. So because of this perceived incompatibility, Greek natural philosophy was usually regarded with suspicion and was therefore rarely taught publicly. Okay? So who are these guys who are praised as advancing Aristotelian natural philosophy if this stuff wasn't being taught publicly? Many of the foremost Muslim scientists and natural philosophers, including al-Biruni, Avicenna, and Alhazen, were supported by royal patronage and did not teach in schools. So they were just like the pet court philosopher, right? They didn't produce students. Without the protection of a strong patron, natural philosophers who took Aristotle as their guide and mentor were subject to attacks and denunciations by influential local religious leaders, because the religious people were suspicious of this stuff, right? A description by F.E. Peters, who studied the fate of Aristotle in Islam, is appropriate. He says, assimilation there was. The entire history of Kalam shows it. That's the a certain strand of bringing Muslim theology together with Greek philosophy. So the entire history of Kalam shows it. But when confronted with radical philosopha, Islamic orthodoxy reacted with determination and frequently with violence. Philosophy and natural philosophy were not to be studied for their own sakes because they might prove harmful to the faith. For example, logic was often characterized as ungodly. So this idea of the handmaiden idea of the sciences, so science is a handmaiden theology, that's an idea you heard in the West, but it didn't really, it didn't remain a dominant way of thinking about it. And just enjoying learning science, natural philosophy for its own sake was considered okay. But in Islam, the handmaiden idea of the sciences took hold and remained. In the Latin West, let me read this. So in the Latin West, the handmaiden idea, which was dominant by the mid-4th century, long before the introduction of Aristotelian natural philosophy in the 12th century, faded away as philosophy gradually became an independent discipline and Aristotelian natural philosophy came to be valued for its own sake. So let's look at a few figures here. So Al-Ghazali, 1058 to 1111, he was deeply suspicious and fearful of the effects on the Islamic religion of natural philosophy. In his treatise Deliverance from Error, he explained that religion does not require the rejection of natural philosophy, but there are serious objections to it because nature is completely subject to God, and no part of it can act from its own essence. The implication is obvious. Aristotelian natural philosophy is unacceptable because it assumes that natural objects can act by virtue of their own essences and natures. That is, Aristotle believed in secondary causation, that physical objects can cause effects in other physical objects. And Islam is got this very totalistic view of the role of God. If it's happening, like God is doing it. It's sort of like hyper-Calvinism or something, you know. God is sovereign over everything. And if you're explaining anything without using God's sovereignty, then you're wrong, you know. In defense of God's role as the direct cause of every effect, the Mutazilites constructed an elaborate doctrine. I had to share this because this is how crazy they got with this. They constructed an elaborate doctrine of continuous recreation, in which God creates the world at one moment of time, and then by ceasing to act allows it to vanish, only to recreate it again in the next moment of time, and again allow it to vanish, and so on. They came up with this absolutely cockamamie view of reality. I'm not saying this was mainstream, but it just gives you an idea of the extraordinary measures they would go to deny secondary cause and effect, right? It had to be all God acting all the time. Al-Ghazali found mathematics dangerous because it uses clear demonstrations, thus leading the innocent to think that all the philosophical sciences are equally lucid. How many have I seen, he says, who err from the truth because of this high opinion of the philosophers and without any other basis? A student who studied these sciences would be infected with the evil and corruption of the philosophers. Few there are who devote themselves to this study without being stripped of religion and having the bridle of godly fear removed from their heads. It's just saying. Telling my wife it's going to be a long one this time. Okay, here's another one. So as one of the greatest and most respected thinkers in the history of Islam, al-Ghazali's opinions were not taken lightly. So he was influential with these views. Now there's Ibn Khaldun. I've heard that name, 1332 to 1406. He condemned the opinions of the philosophers as wholly wrong. He informed his fellow Muslims that the problems of physics are of no importance for us in our religious affairs or our livelihoods. Therefore, leave them alone. Logic was potentially dangerous to the unprepared faithful. Whoever studies logic, Ibn Khaldun warned, should do so only after he is saturated with the religious law and has studied the interpretation of the Quran and jurisprudence. No one who has no knowledge of the Muslim religious sciences should apply himself to it. Without that knowledge, he can hardly remain safe from its pernicious aspects. A general uneasiness about natural philosophy seems to have been widespread. And this perhaps explains why natural philosophy was never institutionalized in Islam, as it was in the Christian West, right? So this positive attitude of the theologians in the West was really key, because without that support, you got what you got in the Saracen Empire among the Muslims, which is that it was a hobby, but it never became an institution. It never became a growing body of knowledge that many people are contributing to, right? Perhaps these difficulties for this is really interesting what he does here, talking about the histories, the growth of Christianity versus the growth of Islam. Perhaps these difficulties for natural philosophy were to some extent consequences of the strikingly different ways in which the two religions were disseminated, and the different cultural and intellectual contexts into which they were propagated. If Christianity was disseminated slowly, permitting centuries of adjustment to the pagan world that it would come to dominate in religion, but that it would eventually dominate it in philosophy, science, and natural philosophy, the religion of Islam was transmitted with remarkable speed in about 100 years, right? Islam conquered very quickly over a vast area, embracing many diverse peoples. In contrast to Christianity, which was a relatively weak force within the Roman Empire for many centuries, and so had to spread its ideas by missionary zeal, it had no armies to compel acceptance. Islam did not have to carry on a dialogue with the peoples it conquered and converted. Where Muslim armies prevailed, the Muslim religion was installed. End of story, right? There wasn't persuasion going on here, or trying to understand the culture and speak to the culture. This is how Christian missionaries think. Muslim didn't work that way. They just say, hey, we're in charge now. Obey. The Muslim religion never went through a period of adjustment to pagan philosophy and learning. Islam, unlike Christianity, did not have to accommodate to a wider culture or accept Greek learning, which it continued to view as alien and potentially dangerous to the Islamic faith. Such a fascinating bit there. So in Islam, natural philosophers were usually distinct from theologians. Scholars were either one or the other, rarely both. Natural philosophy was always on the defensive. It was viewed as a subject to be taught privately and quietly rather than in public. It was taught most safely under royal patronage, as seen in the careers of some of Islam's greatest natural philosophers. Within Western Christianity in the late Middle Ages, by contrast, almost all professional theologians were also natural philosophers. The structure of medieval university education made it likely that most theologians had early in their careers actually taught natural philosophy. The positive attitude of theologians and religious authorities toward natural philosophy within Western Christianity meant that the discipline could develop more comfortably and consistently in the West than in Islamic society. In the West, natural philosophy could attract talented individuals who believed that they were free to present their opinions publicly on a host of problems that formed the basis of the discipline. Although Greco-Roman learning was suspect in the West, it was not considered an enemy, and its potential utility was recognized early. And this is how Rodney Stark put it. He said, there was the hostility on the one hand in Islam, for example, but then the Muslims who did consider Greek philosophy tended to be very sort of slavish towards it and too submissive to Aristotle. Whereas for the Christians, they weren't afraid of it, but they weren't submissive to it either. They were like, this could help us understand the world. Take the best, leave the rest. It was very like utilitarian approach, right? Very pragmatic approach. Although many Christian churchmen, such as St. Augustine, proclaimed the superiority of the church over the state, the Christian church did acknowledge and accept the separation of church and state, which allowed for the development of a secularly oriented natural philosophy. In medieval Islam, by contrast, truly secular government was absent, and church and state were one. And so he argues that where religion is strong, like with Islam, it's likely to dominate secular activities like science, unless the activity is recognized as one of these: independent, protected by a secular state, favorably regarded by religious authorities, right? Because the church looked with favor on science, secular authorities adopted a beneficial approach toward it. So protected by the secular state, number two, right? They had no reason to oppose science and natural philosophy. They found many occasions to favor the disciplines. And as we've already discussed, natural philosophy in the West was favorably regarded by religious authorities. So that's those two, second and third condition: protected by a secular state, favorably regarded by religious authorities. And that yielded a certain independence, that first condition, because of the other two aspects during the late Middle Ages. Certain aspects of their religion may also have drawn Christians to Greek philosophy. One example is the problem of the Eucharist, with its difficulties about the nature of substances and their attributes. Adoption of a Trinitarian position placed enormous metaphysical burdens on Christianity. You had to think about the nature of the Godhead, right? To help explain such theological difficulties, scholars deemed the concepts and terminology of Greek metaphysics essential. Logic was considered important. St. Augustine regularly used logic in resolving theological problems, especially on the Trinity, De Trinitate. Strictly Unitarian religions, such as Islam and Judaism, needed no such metaphysical assistance or apparatus to expound on the nature of God. It was simple. God is one, that's it. Islam was much less driven by inherent theological needs to seek out Greek philosophy than was Christianity. Indeed, Islamic theologians discouraged analyses of the Quran and prevented the development of a speculative theology. So this is one of those things where you can be anachronistic isn't the right term, right? But you can be like, oh, Muslim theology, like our theology in the West. No, extremely different. Yes, they're both theologies, but sort of how they come at it is quite different. What's considered fair play in theology is quite different in Western Europe from Islam. So medieval Christianity showed it was prepared to do more than merely tolerate the existence of natural philosophy. It actively promoted it in an open and public way. So we could easily imagine a scenario in which hostile religious authorities might have sought to prevent the pursuit of science and natural philosophy. Um, but Christians avoided this. Consequently, the religious attitude in Christendom favored natural philosophy more than it did in Islam, where Islam's theologians were largely hostile to it. Because of a fear that natural philosophy was potentially dangerous to the Muslim faith, and perhaps for other reasons as well, Islam never institutionalized natural philosophy, never made it a regular part of the educational process. It is unlikely that most Islamic thinkers thought that God's handiwork was fathomable, although occasionally someone like Averroes would argue that the Quran mandated that a good Muslim study nature. But he's the exception, right? It is remarkable that after approximately 300 years, during which science, logic, and natural philosophy were available in Islam, Averroes felt compelled to justify their study in a treatise called On the Connection Between Religion and Science. This author here knows of no analogous treatise in the late Latin Middle Ages in which any natural philosopher or theologian felt compelled to determine whether the Bible permitted the study of secular subjects. It was simply assumed that it did. So that's one open hostility or lack of enthusiasm of Islamic theologians and religious authorities. That's one major reason why an institutional base comparable to the universities in the West failed to develop. Let's see. The university as we know it today was invented in the late Middle Ages. This is contrasting with what happened in the West, right? Universities were powerful and highly regarded institutions, corporate entities with numerous privileges that increased century by century. Despite plagues, wars, and revolutions, they carried on, giving to natural philosophy and science continuity and permanence. This is something I think about more and more as I study what influences and what doesn't. Continuity is really significant. Having an institutional basis, keeping it going, keeping it from being subverted, like everything is being right now in the modern West. It's so important. They could have this continuity because the church and the theologians who were the guardians of church doctrine had acquiesced to Aristotelian natural philosophies having a major role in education. For the first time in history, science and natural philosophy had a permanent institutional base. No longer would the preservation of natural philosophy be left to the whims of fortune and Islam. The whims of fortune and to the efforts of isolated teachers and students. Before 1500, the exact sciences in Islam had reached lofty heights, greater than they achieved in medieval Western Europe, but they did so without a vibrant natural philosophy. In Western Europe, natural philosophy was highly developed, whereas the exact sciences were merely absorbed from Greco-Arabic science and maintained at a modest level. But then it flipped. After 1500, Islamic science effectively ceased to advance, but Western science entered upon a revolution that would culminate in the 17th century. So what can we learn from all this? And he proposes the following sort of fascinating idea here. The exact sciences are unlikely to flourish in isolation from a well-developed natural philosophy, whereas natural philosophy is apparently sustainable at a high level, even in the absence of significant achievement in the exact sciences. I submit to you something I've been thinking about a long time. Search on my Twitter for the term the word just went out of my mind. The Russian guy who dominated biology with his crank theories. It'll come to me. Anyway, I've been talking about this for years on Twitter, that science is absolutely doomed right now. We think we can just continue to advance in the exact sciences without the underlying basis, without the metaphysics, without the natural philosophy. And I think it ain't going to happen. I think we're already seeing it. The wokeness or whatever you want to call it that's been coming for the humanities, it's creeping its way into science too. There's certain assumptions that gave us modern science. As modern people reject those assumptions, they won't see the point in doing science anymore, right? For example, right now, it's just seen as like power relations. Why should we respect Western ways of knowing over African ways of knowing or whatever, or whatever minority they're pushing to be. Trans ways of knowing. I don't know what will be next. Why should we respect that? You're already hearing this sort of thing. Why should we reject magic? Why shouldn't we bring magic in here into this discussion too? It seems crazy, right? But this is happening right now in our institutions. It's eating away at the foundations. And we're just assuming that we will just continue to make progress in the exact sciences. We'll continue to have medical advances and so on and so forth. But if we lose the basis long enough, if the basis gets eaten away enough, it'll all stop. There's no reason to believe that science will keep going. It's a historical anomaly, as this whole series is highlighting. It's a historical anomaly, and we can lose it. We can absolutely lose it. So in Islamic society, where religion was so fundamental, the absence of support for natural philosophy from theologians, and even their open hostility toward the discipline might have proved fatal to it, and eventually to the exact sciences as well. So it was really important that the theologians, Lysenko, thank you, Lysenkoism. Look up the term Lysenko, radical lib space Lysenko on Twitter. You'll see me talking about this for many years. Because this has been bothering me and worrying me for some time, and the worries I had 15 years ago or whatever, however many years ago, have only become really apparent at this point. Okay, now let's turn to the Byzantine Empire and do a contrast with that. Now we must briefly examine the eastern part of the Roman Empire, which developed a brand of Christianity that differed considerably from its Western counterpart. This is really challenging for Christians and for orthobros, right? Because here he's saying not even Christianity was enough, because we had a distinct Christian civilization alongside Western Europe, which was Eastern Christianity, Byzantium, right? And they didn't develop science. Now, they did get trashed by the Muslims around the time that modern science was developing, but nevertheless, they really didn't even develop the preconditions or the foundations that we see with natural philosophy. So, what's the difference between East and Western Christianity that yields such different results in regards to science? One of the major features of Western Christianity was its differentiation from the secular state. As we know, church and state were in competition in the West, but one never dominated the other. But Byzantium was essentially a theocratic state. The distinction between church and state was largely non-existent. The emperor was regarded as the viceroy of God and a sacred leader. Because Greek was their native language, they could read Greek works on science and natural philosophy directly without need of translation in the Byzantine Empire. So it seems like that would have given them a big leg up, right? The West is like waiting for these translations to show up. They already have it. They're all Greek speaking, Greek reading. The learned people in Byzantium. These Greek works of science and natural philosophy were available. They were readily available in the libraries and depositories of Constantinople and the surrounding region. Indeed, most of our manuscript sources for Greek science came from the Byzantine Empire. But despite these advantages, scholars in Byzantium failed to capitalize on their good fortune. The greatest part of the literature on these subjects lies as yet unpublished, and therefore, for the most part, unread. So he says, little caveat here. It could be that if we dig into the archives, we'll find that there were Byzantine scientists who were having some great moments, but they didn't have any influence. The most significant scientific accomplishments occurred relatively early in the history of the Byzantine Empire, primarily during the 4th to 6th centuries. And at that point, do you credit it to the ancients, the Romans, or do you credit it to the Byzantium? And it gets a little murky at that point in history, right? Noteworthy contributions were made in mathematics and engineering, and Greek commentators such as Themistius, Simplicius, and John Philoponus wrote Aristotelian commentaries that eventually exerted influence in Islam in the Latin West. But after the Emperor Justinian ordered the closing of Plato's Academy in Athens in 529 on religious grounds, Byzantium would honor the ancient Greek tradition only sporadically. Why, during the last 800 years of the Byzantine Empire, did scholars add little of significance to their enormous legacy of ancient Greek science and natural philosophy? Why did the civilizations of Islam and Western Europe outperform Byzantium by large margins, despite a total reliance on translations and with fewer ancient works available? So they had the goods in terms of the ancients, right? The ancient natural philosophy. They could have been moving faster than everybody. They could have had the jump on everybody. He does talk about war, but he kind of dismisses that. He says, was the Orthodox Church in Byzantium an obstructionist force in science and natural philosophy? It did occasionally interfere, but he doesn't think it was a major factor. The church itself drew upon ancient Greek traditions, but it never had an easy relationship with pagan thought. Throughout the history of the Byzantine Empire, church authorities insisted on the handmaiden approach to philosophy and to secular learning in general, showing hostility toward any attempt to study such subjects either for their own sakes or for the sheer love of knowledge. The church's theologians were only occasionally natural philosophers. Yeah, Old King Cole says, Rodney Stark really opened my eyes to how much science is the product of Western Christianity. Yes, that's the first place I encountered this contrast between Western Christianity, Islam, and Byzantium. So the Byzantine scholarship, the character of it is revealed here by the Metachites. Metachites spoke for Byzantine philosophers when he declared, the great men of the past have said everything so perfectly that they have left nothing for us to say. So this is this submissive attitude. Hey, wow, those guys were amazing. We can't build on them. We can't critique them. We can't think about what they said. We can't contend with it, right? Ask questions of it. We contrast this attitude with that of scholars in Islam and the Latin West, who also respected the ancients, but were often prepared to go beyond them and add to the sum total of knowledge. Byzantine scholarship stands in sharp contrast to the questions tradition in the West, where authors were forced to confront one issue after another and to devise reasoned responses that might or might not agree with the author of the text. A Byzantine scholar has said, the prime purpose of scholarship as practiced in late Byzantium seems often to have been the gratification of one's own ego, and sometimes the discomfiture of one's intellectual opponents. Beyond the discipline of the master-pupil relationship, there was little observable cooperation among Byzantine scholars. Each worked alone as an individualist. Only rarely did they collaborate in their researches. So there were schools of thought in the West, and there really weren't in Byzantium. There were just these individual one-off scholars. Also, there was this that might have had a bit of an impact. The ill fortune that befell John Attalos in 1082. He was a professor of philosophy in Constantinople, and he was declared a heretic because he came to love Hellenic learning too much. His mistake was widely known because, quote, his errors were read out in every Orthodox church on the first Sunday of Lent as a perpetual reminder and warning. Don't get into the Greek stuff too much, guys, or you might be declared a heretic like this guy. So that had a chilling effect, I'm assuming. Neither church nor state, and they were often one and the same, ever institutionalized the study of natural philosophy and science, and this Byzantium differed little from Islam. Islam, however, treated the initially alien disciplines of Greek science and natural philosophy more enthusiastically and successfully than Byzantium treated its own native Greek heritage. The real intellectual significance of Byzantine, giving credit where it's due, which this author is very careful to do, lies in the preservation and transmission of the Greek scientific tradition. For this incalculable contribution, the Byzantines have rightly been called the world's librarians in the European Middle Ages. In this sense, the Byzantine Empire played a monumental role in the history of science and learning. So they didn't build on it particularly, they didn't add much to it, but they transmitted it. And that, the Muslims picked that up. They did do some building on it, modest building on it, and then that stuff started getting translated into Latin by the Western European Christians, And then the whole story we've been telling, building the foundations, which eventually became modern science, or upon which modern science was able to build. So, so these preconditions, the three preconditions he's talked about, right? What were they? Yeah, the translations of the ancients, the Greco-Islamic learning, the translations, the universities, and then the theologian-natural philosophers. You know, the fact that the theologians were all supportive because they were natural philosophers themselves. Though all those preconditions were absolutely vital for the emergence, and they qualify of modern science. They qualify as foundational elements, but they were not in themselves sufficient. The reasons why science took root in Western society must ultimately be sought in the nature of the science and natural philosophy that were developed. So you had all this context, right? But what about Aristotelian natural philosophy itself? Although the Latin Middle Ages, in regards to the exact sciences, although the Latin Middle Ages preserved the major texts of the exact sciences and even added to their total, I am not aware of methodological or technical changes derived from these works that proved significant for the scientific revolution. Nevertheless, during the Middle Ages, there was considerably more innovation in natural philosophy than in the exact sciences. Medieval natural philosophy shaped what was to come more than did the exact sciences. And here he talks about natural philosophy as the mother of all sciences. With natural philosophy, we are not concerned with the mere preservation of Greco-Arabic knowledge, but rather with the transformation and inheritance into something ultimately beneficial for the development of early modern science. Natural philosophy as the mother of all sciences. And this is, I just had to share this. This is quite interesting. He talks about how almost all other sciences besides astronomy, mathematics, optics, and medicine, which were already considered independent sciences in the Middle Ages, almost all other sciences, physics, chemistry, biology, geology, meteorology, psychology, all their subdivisions and branches, they emerged as independent disciplines from within the matrix of natural philosophy during the 17th to 19th centuries. They emerged only slowly, and most were not recognized as distinct subjects until the 19th century. Adam Smith, an example I love to bring up, was a professor of moral philosophy. He was not a professor of economics. That was later that economics became its own discipline. Same idea here. By the mid-19th century, natural philosophy was still widely taught in colleges in the United States. A definition of it given for a course of lectures at Dickinson College in Pennsylvania in 1845 declared that natural philosophy may be considered as the science which examines the general and permanent properties of bodies, the laws which govern them, and the reciprocal action which these bodies are capable of exerting upon each other at greater or less distances without changing their matter. Sounds very Aristotelian, right? I skipped something. Okay. The mother of all sciences had given birth to her numerous progeny, many of whom were apparently reluctant to leave her congenial abode to dwell in as yet new and unfamiliar surroundings. The universities of Western Europe during the late Middle Ages, The natural philosophy that spawned these sciences over many centuries were developed in the universities of Western Europe during the late Middle Ages. It was a unique development in the history of the human race. They converted Aristotle's natural philosophy into a large number of questions that were put to nature on a range of subjects that would eventually crystallize into the sciences. So you had all these questions, and those questions eventually became modern science. By the end of the 17th century, new conceptions of physics and of the cosmos as a whole drastically altered natural philosophy. Aristotle's cosmology and physics were largely abandoned, but his ideas about many other aspects of nature, including, for example, material change, zoology, and psychology, were still found useful. In biology, Aristotle's influence continued into the 19th century. Medieval natural philosophers were interested in the ways that we can know and approach nature. That is, in what might be called scientific method. They sought to explain how we come to understand nature. even though they rarely pursued the consequences of their own methodological insights. They'd be like, how could we learn about this? But then they wouldn't go like do experiments. That came later, right? Thomas Bradwardine departed from Aristotle when he realized that natural processes had to be represented by mathematical functions that hold for all values and are therefore continuous. Scholastic authors frequently introduced infinities and infinitesimals into nature, and were aware that one could treat the infinitely large and the infinitely small in the same manner as one treated finite quantities. The mathematical treatment of qualities was characteristic of medieval natural philosophy. So they didn't just discover math with Galileo, right? They were already using math. The problems were usually imaginary and hypothetical, but the application of math to solve such problems was commonplace. By the 16th and 17th centuries, mathematical ways of thinking, if not math itself, had been incorporated into natural philosophy. The stage was set for the consistent application of natural philosophy to real physical problems, rather than to the ways in which qualities were imagined to vary. Most of the methodological contributions to science were philosophical. They formulated sound interpretations of concepts such as causality, necessity, and contingency. Some scholars, and John Buridan was one of them, concluded that final causes were superfluous and unnecessary. For them, efficient causes were sufficient to determine the agent of a change. He also addressed another major methodological development, Buridan, when he insisted that scientific truth is not absolute like mathematical truth is, but has degrees of certitude. The widespread use of the principle of simplicity was a typical feature of medieval natural philosophy and was characteristic of science in the 17th century, as when Johann Kepler declared that it is the most widely accepted axiom in the natural sciences that nature makes use of the fewest possible means. Thus, medieval natural philosophers sought to investigate the common course of nature, not its uncommon or miraculous path. And as we've discussed, thought experiments, counterfactuals. Let's see. One of the most fruitful ideas that passed from the Middle Ages to the 17th century was that God could annihilate matter and leave behind a vacuum. Yeah, okay, and here's an example of this. Gassendi, Pierre Gassendi, 1592 to 1655, French philosopher. He concluded that an infinite three-dimensional void space existed. Listen to how he thinks. It is frequently necessary to proceed in this fashion in philosophy, as when they tell us to imagine matter without any form, in order to permit us to understand its nature. Therefore, there is nothing that prevents us from supposing that the entire region contained under the moon, or between the heavens, is a vacuum. And once this supposition is made, I do not believe that there is anyone who will not easily see things my way. And then the author goes on with examples from Hobbes and Locke, who I never thought of as natural philosophers, but there you go. They evidently they are key to the development of some of these things. The power of counterfactuals is nowhere more impressively illustrated than in the principle of inertia, which Newton proclaimed as the first law of motion in the mathematical principles of natural philosophy. Quoting Newton, every body continues or perseveres in its state of rest, or of uniform motion in a right line, unless it is compelled to change that state by forces impressed upon it. Another legacy from the Middle Ages to early modern science was an extensive and sophisticated body of terms that formed the basis of scientific discourse. These included potential, actual, substance, property, accident, cause, analogy, matter, form, essence, genus, G-E-N-U-S, species, relation, quantity, quality, place, vacuum, infinite. All of this is vocabulary coming from the natural philosophers of the Middle Ages. New concepts, terms, and definitions were added, most notably in the domains of change and motion. Medieval natural philosophers distinguished between dynamics, or the causes of motion, and kinematics, or the spatial and temporal effects of motion. They also differentiated between the measure of the intensity of a quality and the total quantity of the quality distributed over an entire subject. They devised an impressive series of new kinematic definitions that were important in the history of physics, including definitions of uniform motion, uniform acceleration, and instantaneous velocity. I mean, this is like bringing me back to my physics class, right? A lot of these terms here. In dynamics, they employed the concept of impressed force, or impetus, as it was often called, which continued to play a role in physics through most of the 17th century. By the latter part of the century, these terms, concepts, and definitions were embedded in the language and thought processes of European natural philosophers. So, medieval natural philosophy furnished at least some of the basic problems that exercised the minds of non-scholastic natural philosophers in the 16th and 17th centuries. We need only mention our earlier discussion of Galileo's treatment of motion, and recall that he was concerned with traditional medieval problems of motion in plenum and void. The resolution of those problems lay at the heart of the new physics that Galileo constructed. The revolution in physics and cosmology of modern science was not the result of new questions put to nature in place of medieval questions. It was, at least initially, more a matter of finding new answers to old questions, answers that sometimes involved experiments. So, the medievals gave us a conceptual apparatus, a way of thinking about things, and even the questions. And then the scientific revolution started to change the answers. Aristotle didn't get that right. We've observed, or we've done an experiment. This is the right answer to that question, right? So think of this huge framework, and then they're just plugging in answers to it, right? Their changes, early modern science, their changes were made mostly in the answers, not in the questions. Although the solutions differed, many of the fundamental problems were common to medieval scholars and to scholars in the period of the scientific revolution that followed. Beginning around 1200, medieval natural philosophers, located largely at the universities, exhibited great concern for the nature and structure of the physical world. The contributors to the scientific revolution continued this tradition, which by then had become integral to intellectual life in Western society. So, as so often with history, right? We're sold something as this drastic change, when in fact there's much more continuity and nuance to it. I feel like I've seen this happen again and again. Man, this is the longest stream I've done in a while. But I am determined to finish this book. Okay, freedom of inquiry and the autonomy of reason. Middle Ages gave a remarkable legacy of relatively free, rational inquiry. Almost from the outset, masters of art struggled to win as much academic freedom as they possibly could. And remember, that wasn't just like, we have a very bad notion of free speech. Rothbard really is good on this, where he says, don't think of free speech as this free-floating thing. It's rooted in property, right? Well, that's how they got free rational inquiry. They had property. The universities were corporations. They had property over which they had jurisdiction. They decided who got degrees and who didn't, who was accepted into their institution and who wasn't. They had the right of exclusion, right? Freedom of association, because they owned the institution, they owned the property. So they had free inquiry because they owned it. That's the only kind of free speech, is I have the freedom to speak on my property, and you don't unless I permit you to, right? So don't think of these things as free-floating rights or something. It's rooted in place. Because of their independent status as a faculty with numerous rights and privileges, they achieved a surprisingly large degree of freedom during the Middle Ages. Although theology was a potential obstacle to the study of natural philosophy, theologians themselves offered little opposition to the discipline, largely because they were too heavily involved with it. The ideal of natural philosophy was to use only reasoned arguments. Medieval natural philosophy was quintessentially rational. By the end of the 13th century, philosophy, including its major subdivision, natural philosophy, had emerged as an independent discipline in the universities. Let's see. Yeah, and then he just talks about how the students of natural philosophy in the 16th and 17th centuries were beneficiaries of all this, the spirit of free inquiry and everything. But most were unaware of their legacy, and they preferred to ridicule Aristotelian scholastics and scholasticism. They were wanting to change things. They needed to change some things, right? Medieval natural philosophy was totally transformed in the 17th century. The medieval scholastic legacy remained, however, in the form of the spirit of free inquiry, the emphasis on reason, the variety of approaches to nature, and the core of problems to be studied, even down to the exact questions, right? The new science also inherited from the Middle Ages the profound sense that seeking to discover the way the world operated was a laudable undertaking. This is something that, thanks for comments reminding me about Rodney Stark. This is something that Rodney Stark really emphasizes, that in some civilizations, the idea that it would even make sense to discover the way the world operated wasn't theologically plausible. They believed in something like the force, right? If there's a divine, it's inscrutable to us. It is just a force out there, an impersonal force. We can't understand it. Maybe it can't understand us. And of course, with Christianity, you have the notion of a personal God who says, "Come, let us reason together," right? So not all civilizations would have even had the philosophical theological framework to consider science a thing you would do, or to even assume that the world could be understood, right? Don't take for granted that that's part of what we get out of Christianity, is just the notion that we can understand the world. God meant us to understand it, that it's not against God. It's not dishonoring the gods to try to understand the world. In fact, as you might know, a lot of the scientists, even the early modern scientists, they saw themselves as doing something that was blessed by God. I am understanding the way God made the world. This is a wonderful thing. I'm seeing into what the beautiful designs that the world made. This leads me to praise God, to understand how intricate and amazing the world is, right? So they didn't see it in stark contrast to seeing it as something that just was an incoherent enterprise, or an evil enterprise. They saw it as a wonderful, ordained, blessed enterprise, right? So 6 essential and innovative features of the new science that came to dominate Western civilization in the 17th century. First, deliberate and recordable experimentation. Second, math as a privileged tool for disclosing nature. Third, the reassignment of the causes of certain perceived attributes of things from the things themselves to the perceptual apprehensions of the observer, the primary and secondary quality distinction. I don't understand that one. 4, the associated plausibility of seeing the world as a kind of machine. 5th, the idea of natural philosophy as a research enterprise rather than as a body of knowledge. 6th, the reconstruction of the social basis of knowledge around a positive evaluation of cooperative research. Before scholars could have an idea of natural philosophy as a research enterprise, they first had to have a natural philosophy that deserved to be characterized as a body of knowledge. Such a body of knowledge was fashioned in the late Middle Ages. Occasional experiments had been made. Mathematics had been routinely applied to hypothetical, although rarely real problems in natural philosophy. Although these new developments in the 17th century represent truly profound changes in the way science was done, he's not denying that, they should be viewed as late developments in a process begun in the Middle Ages. Without the foundations laid down in the Middle Ages and described in this study, 17th century scientists could not have challenged prevailing opinions about the physical world because there would have been little of substance to challenge in physics, astronomy, and cosmology. As we know, as scholars know, we're usually kind of in dialogue, right? Even with someone we disagree with, it gets us to think about things, to be in dialogue. So they were whether they wanted to acknowledge it or not, they were in dialogue with the questions that had been posed and wrestled with prior to them. Two vital and from the 3 preconditions described earlier, 2 vital and unique entities emerged during the late 12th and 13th centuries in Western Europe: the universities and the class of theologian-natural philosophers. Their existence permitted natural philosophy to develop in ways that had never before been feasible and to flourish. So, the relationship between medieval and early modern science. This author contends that the medieval period in Western Europe has been grossly underestimated and even maligned. I don't know if you can imagine our heritage being maligned, but just use your imagination and imagine such a thing, right? He says two momentous events of the 17th century were responsible for this state of affairs: the scientific revolution itself and the condemnation of Galileo by the Catholic Church in 1633. The supporters of Aristotelian natural philosophy by this time were presented as insensitive dullards, as logic choppers and wordmongers who were opposed to progress. The image of Aristotelian natural philosophers and scholastics was one of an old guard dedicated to the status quo. This just sounds like Kuhn's scientific revolutions, you know. However much modern science owed to them, they wanted to distinguish themselves as a new paradigm. You know, fair enough, I guess. But yeah, Dark Ages was a Jacobin lie. Totally agreed. That's a big emphasis of my channel. No one contributed more to the formation of this image than did Galileo, and I didn't know about this. In his famous Dialogue on the Two Chief World Systems, 1632, he left an indelible picture of scholastic ineptitude and wrongheadedness. Okay, so Galileo did a little bit of propaganda here, okay? He created a character named Simplicio, a fictional character named after Simplicius, the well-known 6th century Greek commentator on the works of Aristotle. And he portrays him as a caricature that was applied to all Aristotelian natural philosophers, not only to those in the 17th century, but retroactively to hundreds of years before, right? Which not fair at all. John Locke, who had been taught medieval Aristotelian philosophy at Oxford, characterized scholasticism as little more than futile verbal gymnastics. By such sustained criticism, Aristotelian natural philosophers were made to appear foolish, ineffectual, and irrelevant. This is reminding me of a little bit after this, the not the Enlightenment, but the Enlightenment thinkers telling us that Columbus had to fight with people who thought the world was flat, which is just a lie, you know. So we see this. We see the people looking backwards and ridiculing the past, you know. I don't like that attitude personally. I kind of get it. They're needing to distinguish their new thing. They do have something new and something valuable, but I don't see why you need to throw the giants you're building on under the bus. The medievals didn't do that. They didn't throw Aristotle under the bus. They honored him and then moved forward, right? I think that's the better attitude. The condemnation of Galileo in 1633 for upholding the Copernican heliocentric system aggravated the situation immeasurably, for the church was viewed as defending and preserving Aristotelianism by coercion. And that's an incident. I have a Russian scholar friend who did some research on the Galileo incident. And that's an incident that, again, is presented without nuance, and there's more that could be said there. Thus, a completely false view of medieval natural philosophy has been perpetuated, and the contextual and substantive medieval achievements in natural philosophy described in this volume have been ignored by those modern historians who have judged late medieval developments by the attitudes that emerged in the 17th century when the new science was struggling to overthrow the Aristotelian worldview. Okay, almost done here. Okay, wait. Okay, yeah. So wrapping it up here. So on the relationship between early and late medieval science, little note here, which is interesting. He says, if the achievements of the late Middle Ages bear such a positive relationship to the early modern period, as he's argued in this book, what about between the early Middle Ages, like from 500 to 1150, and the late Middle Ages? Is there a similar good relationship? And he's like, yeah, I don't think so. The relationships are radically different. With a few minor exceptions, Greek science was absent during the early Middle Ages. Euclidean geometry, for example, was virtually non-existent. The Greco-Arabic science that entered Western Europe in the 12th century was not merely the enrichment of a somewhat less developed Latin science, it was a dramatic break with the past and a new beginning. So there was a real revolution in the 12th century as this stuff came in and scholars started to absorb it and build on it. And he says, let's acknowledge it for what it was. Logic, science, and natural philosophy were henceforth institutionalized in the newly developed universities. So, giving credit to everybody here, he says, Greco-Arabic Latin science, a triumph of three civilizations. The modern science that emerged in the 17th century in Western Europe was the legacy of a scientific tradition that began in ancient Greek and Hellenistic civilization, was further nurtured and advanced in the far-flung civilization of Islam. The books were saved by the Byzantines, as he said before, and was brought to fruition in the civilization of Western Europe beginning in the late 12th century. My primary concern has been to explicate the last or Latin part of this extraordinary tripartite sequential process. It was possible only because scholars in one civilization recognized the need to learn from scholars of another civilization. Latin scholars in the 12th century recognized that all civilizations were not equal. They were painfully aware that with respect to science and natural philosophy, their civilization was mostly inferior to that of Islam. They faced an obvious choice: learn from their superiors or remain forever inferior. They chose to learn and launched a massive effort to translate as many Arabic texts into Latin as was feasible. If we move back a few centuries, we see that the same phenomenon occurred in the civilization of Islam. By the late 8th century, Islamic scholars speaking and writing in Arabic became aware of a vast body of Greek scientific literature. Recognizing the absence of scientific literature in Arabic was a serious they recognized that was a serious cultural and intellectual deficiency. They set out to translate Greek science and natural philosophy into Arabic. If Muslim scholars had assumed they had nothing to learn from dead Greek pagans, and if Latin Christian scholars had assumed they had nothing to learn from dead Muslim heretics, the great translation movements of the Middle Ages would never have occurred, impoverishing history and delaying scientific development by many centuries. This did not happen, and we can look back upon Greco-Arabic, Latin science, and natural philosophy as one continuous development. It is truly a progression toward modern science and represents one of the most glorious chapters in human history. Amen. This is one of the reasons Radcliffe reminds me of what Aristotle would have looked like. Interesting. This is one of the reasons that I thank you, anyone who was able to get through all this. This is intense here. Oh, wait, that's not the screen I need. Excuse me, I'm going to switch to just me here. Just about lost my voice doing this, but I just really wanted to finish this. I got a speech in 2 weeks, and I got to completely focus on that. So I did want to highlight a few comments. A couple things to do to wrap this up. Thanks, everyone who is supporting me at Subscribestar and with Super Chats and stuff. I did see one comment I wanted to call out. Did not look through all the comments, but totally agree. Old King Cole says, I came to the realization that science was dying listening to Jordan Peterson. He was doing one of his, it's like science is based on an underlying metaphysical, blah, blah, blah. Yeah, absolutely. I agree. I think Jordan Peterson gets it, that we're going to lose science because we're losing the foundations. Or it is under threat, absolutely. The idea that it's just going to be, over in English literature, they're kind of crazy, but, over in physics, we're fine. We'll never be affected by the woke and all this stuff. Yeah, good luck with that. Okay, so did want to bring up, if this topic interests you, Edward Feser's Aristotle's Revenge. He's the one who recommended the book we just finished going through, Edward Grant's Foundations of Modern Science in the Middle Ages. I just want to give you a very, very tiny taste of what he's up to here. And you'll see why I wanted to share this. It totally connects with everything we've been talking about here. The central argument of this book, Ed writes, is that Aristotelian metaphysics is not only compatible with modern science, but is implicitly presupposed by modern science. Many readers will be relieved to hear some immediate clarifications and qualifications. First, I am not talking about Aristotle's ideas in physics, as that discipline is understood today. For example, I'm not going to be defending the claim that the sublunary and superlunary realms are governed by different laws, or the doctrine of natural place. I am talking about the philosophical ideas that can be disentangled from the outdated scientific framework, such as the theory of actuality and potentiality, and the doctrine of the four causes. These are, again, metaphysical ideas rather than scientific ones. To be more precise, they are ideas in the philosophy of nature, natural philosophy, which I regard as a subdiscipline within metaphysics. Second, he says, I am not arguing that working scientists in general explicitly employ or ought to employ these philosophical ideas in their everyday research. I am arguing that the practice of science and the results of science, at least in their broad outlines, implicitly presuppose the truth of these ideas, even if for most practical purposes the scientist can, in his ordinary work, bracket them off. I am primarily addressing the question of how to interpret the practice and results of science, not the question of how to carry out that practice or generate those results. And then, as I would argue, you lose the metaphysics and you lose, you kill the golden goose that lays the golden eggs. The golden eggs are that we get scientific advances and we're able to have amazing technology and medical advancements and so on and so forth and fly to the moon and blah, 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 right? Those are the golden eggs. The goose, in my view, is the metaphysical assumptions, the almost by now hidden spiritual and divine assumptions about God that lead us to think that it makes sense to explore the world, to look for truth, that there's even a point to doing that, that there's even any hope of success, that science is about something besides power relations, white people exercising their power over black people or something like that, that there's something else here, that we can find truth, you can find the divine plan that he's laid out in nature, right? Let's see. I'm just going to glance over comments real quick and then wrap it up. Thanks all. Let's see. Okay, yeah, I'll probably just stop. Okay, yeah, wow, long stream. How long did I go here? Not quite 3 hours, but over 2.5 hours. So thank you all who stayed with me. Should be back with Black Horse next week, and then the week after that, I've got the conference, so I'm not going to try to do a show in 2 weeks because I'll be traveling early the next morning to get to the conference. And thanks for your support, which allows me to be the sort of person they would invite to speak. In fact, I just saw the schedule. We'll see if they stick to it, but I'm opening the conference again with my talk. So pressure is on, and my talk is definitely not ready. So wish me luck with that. Pray for me so I can bring it all together and do something good. Okay, hopefully see you guys back next week with Black Horse. Yeah, Sonny Jim says that there are indeed objective truths, not postmodernist subjective truths. Exactly. Thanks for supporting me through this series. I don't think this was the most popular series I did. I think Left-Wing Terror was much more accessible for people. But to me, this is just so fascinating. It's such an important part of our history, our heritage. It's something we are, I'm afraid we're going to lose if we don't fight for it. So understanding how we got it in the first place, I think, is really key to not losing it. So thank you, TCOG, for your kind comment. Okay, and that's it. And let's see if the credits will roll right to thank all my supporters.